So hello everyone, Charu from IIMT College of Management. I will give you the session on the topic stack from the subject data structure. Okay. So this session will help you to understand the concept of the stack and what is the purpose of the stack. Okay. So let's begin. So as you all see, we have a picture like stack of coins, stack of plates, can of tennis balls, and the stack of books. So basically, stack is widely used a linear data structure in modern computers in which insertion and deletion of an element can occur only at one end. Okay, that is the top of the stack, like the stack of a coin. Okay, it is used in all of those applications in which data must be stored and the retrieve in the last. An everyday analogy of the stack data structure is a stack of a book on a desk, stack of a plates, table tennis, stack of bottles, Anju or redo mechanics in the text editor, etc. So basically a data structure, a linear data structure where we use a stack. So basically a stack in which all the insertions and the deletions of the entries are made at one end, that is the top of the stack, and the last entry will be removed first. That's why it's called the last in, first out, and it always follows the LIFO manner. So here are the some key points of the stack, and it is a stack, and it is called a stack because it adapt the real like environment. Like we have some pillars of the books, we have some stack of the plates. Okay, so a stack is an abstract data type with the predefined capacity, which means data can be stored the elements of the limited set. It is a data structure that follows some order to insert and delete the elements, and that order can be LIFO or the FIFO. So basically a stack is an abstract data type, so commonly used in most programming language, and it is named stack as it behaves like real word stack. For example, a stack of a card, another pile of the plates, as you are having, and we all are having and the see in these pictures. So you can explore. There are the example of the stack. We have some data elements in stack. We can push the data elements and then we can pop out the elements from the stack. So this hierarchy follows the last in and first out. Basically, stack can be implemented by the use of array, pointers, and the linked list. So stack can either be fixed size or dynamic. So we have some operations in the stacks. So these are the examples of the operations. So we have push operation, that is add element to the stack. Then we have a pop element, which is going to remove top element from the stack. Then we also have a top, which indicate the top element item without removing it. Okay. So also we have a clear and is empty or the size. Basically all these operations are using in stacks. So let's check out some basic operations. Like we have some stack over here. If we try to create some stack, basically every time we have to insert some element. That means we have to push the elements. If we try to focus in this example, that is false, because whenever if the stack is empty, that means there is no element. Okay, so every stack which is having the operations of empty, that will be no element is having. Next, here top is indicating the 5, 1, and 3. Is it true or false? No, top will be only the 5. So there will be error of underflow. Okay, some basic operation we cover here. So we have to create a stack, and this will leave the stack empty. So test whether the stack is empty first of all, test whether the stack is full, return the size, that is the number of the entry of the size stack, and retrieve the top entry, because every time whenever we want to fetch an element, it always retrieve from the top. So provided the stack is not empty, whenever you retrieve the top, pop the entry off the top of the stack, and that will provided the stack is not empty. Okay, So push a new entry onto the top of the stack. This is provided that the stack is not full. So print all the entries of the stack. Like I'll give you some example. What is the purpose of push and what is the pop operations in the stack? So just look at all of you in that picture. So whenever we are going to push a box in a stack, it always go down in the stack memory. Okay. So again, I'm going to push a box B into the stack. So it will go on the top of the element of A. Whenever I repeat and I pop an element from the stack, which element is having the topmost element in the stack will always delete it from the stack. And this is the pop. I'm going again, pop operation from stack, and that time my stack is empty. If I'm again going to push a box C onto the stack, and it will automatically go onto the stack. Again, I'm going to push the element box D in the stack, and then the box D will be focused or will be aligned on the top of the C box. And again, if I'm going to push another box E, that will be going to fix, that will be placed over the D box. I hope that some picture must be clear out. Next, if we want to create the stack, we can use constructor to initialize a stack. First of all, we are using the stack. We just create a stack by using the constructor. We just predefine. After that, we can initialize the stack. Okay, like here is an example of stack. We are right now, we did not have any elements. So my count will be the 0. And this is my entry point, and my stack will go on up to nth element. And this is the maximum size of my array. Okay. Every time whenever I will go to insert the element that is having the limit. So every time that will be going to -12 element. Then we have a push operation. Let's focus why and what are the purpose of push operation and how we to achieve. So first of all, these are the some steps. Before inserting an element in a stack, we have to check whether the stack is full or not. Okay. So if we try to insert the element in a stack and the stack is full, then the overflow condition occurs. So every time whenever we want to insert element in a stack, we have to check if my stack is having some space or not. Okay. So if there isn't space, then we can initialize the stack. So if we set the value of the top as -1 to check that the stack is empty. Okay, so -1 is always shows that my stack is empty. So when the new element is pushed in a stack, first the value of the top gets incremented, and the top is equals to top plus 1, and the element will be placed at the new position of the top. Okay, the element will be inserted until we reach the maximum size of the stack. So every time the stack will be full, we cannot insert the another element. That means we are reaching the maximum size of the stack. So next we have a push operation. As you all see, here is some example picture that like right now, first of all, my stack is empty. That means my top always will be, I'm focusing on the -1. That means my stack is empty. There is no element in the stack. Next, if I want to push element top, so my top will be incremented by 1. So here my top is 0. Again, if I try to push element 20 in my stack, so my top will be incremented by 1, and here my top will be 1. Next time, if I want to push another element that is 30, then top will be 2. And if I push 40, that means my stack is full here because my top is 3 after pushing or after inserting the element push 40. So let's talk about the pop operations. If we try to pop any element, that means we are deleting some from the stack. So before deleting the element from the stack, we check whether the stack is empty or if we have some elements present there or not. So if we try to delete the element from the empty stack, then the underflow condition occurs. That means there is no element which we try to delete from the stack. If the stack is not empty, then ever we first access the element which is pointed by the top. Okay, once the pop operation is performed, the top is decremented by 1. That is top equals to top minus 1. So please focus every time whenever we are going to push, we have to increment the top, and whenever we are trying to pop, perform the pop, we have to decrement my top. Okay. So here is the example for the pop operation. Here is, I'm giving the same example which I take the previous session. So here the stack is full. Okay. So my top is 3. And if I try to pop the element, so my top will be decremented by 1 minus 1. So I will pop 40 because 40 is on my top. Okay. So after again, if I want to pop another element, my next element is 30. So 30 will be pop out from the top, and the top pointer will be decremented by 1. Again, if I try to pop another element from my stack, because right now topmost element is my stack is 20, so the 20 element will be deleted from the stack and the top will be 0, because every time whenever we are trying to perform the pop operation from the stack, my pointer will be decremented by minus 1. So again, if I try to perform another pop operation, the top will be minus 1 and we deleted the element 10. And again, if I again try to pop another element from my empty stack, then the underflow condition occurs because here there is no element in my stack. So I'll give you the some clear picture of how to work in a stack whenever we are trying to work in a stack. So first of all, we have to create a pointer that is the top. The pointer is called top, that is used to keep track of the top element of the stack. So whenever we initialize the stack, we set its value to minus 1 so that we can check if the stack is empty by comparing top equals to minus 1. On pushing an element, we can increase the value of the top and place the new element in the position pointed by the top. Okay. On popping an element, we return the element pointed to by top and reduce its value. Before pushing, we check if the stack is already full or not. Okay. And before popping, we have to check if already empty or not. Is there any element present before trying to perform operation pop? Okay. So here are some application of the stack. So first of all, we'll talk about the balancing of stack symbols. So basically, stack is used for balancing a symbol. For example, like we have a code, main code. In here, we just try to print some command, print some word that is hello. So as we know, each program has an opening and closing braces like this. Okay, when the opening braces comes, we push the braces in a stack, and when we closing the braces here appear, we pop the opening braces from the stack. So therefore, the next value come out to be 0. If any symbol is left in the stack, it means that the some stack occurs in a program. So we can also perform string reversal. Stack is also used for the reversing a string. For example, if you want to reverse a string, like we have hello, and if we try to perform retrieval the string, first of all we have to push all the elements, all the characters in the stack, and after then we then just pop elements one by one. So after popping all the elements from the stack, we have a string which is reverse. Okay, and if I again try to pop those elements, we can get the reverse string. We can also perform undo and redo because it can also be used for performing undo and redo operation. So like we have an editor in which we write A and then B and then C. Therefore, the text writer in editor is A, B, C. So there are all three states A, AB and ABC which are stored in a stack. There would be two stacks in which one stack shows undo state and the other shows redo state. Okay, so if we want to perform undo operation, we want to achieve AB state and then we implement the pop operation. We also use stack in the recursion. I hope all of you know about the recursion. Basically, recursion means that the function is calling itself again. Okay, to maintain the previous state, the compiler create a system stack in which all the previous records of the functions are maintained. So we can also evaluate the arithmetic expression. So basically, if a stack is used, we can stack use in an effective manner that data structure for evaluating arithmetic expression in a programming language. And arithmetic expression consists of operands and operators. So in addition to operators and operands, the arithmetic expressions may also include parentheses like left parenthesis and the right parenthesis. So here are some example, like if we try to convert some mathematical equations, we have some operators and operands. So there are some precedents, and like if we have exponential, so it is having the highest. If we try to solve these type of problems, first of all, we are going to solve the exponential, then we have the priority multiplication and division, and after then we have the priority addition and subtraction, and after then other operators will come. So like we are going to evaluate the arithmetic expression, right? We require the two steps. First of all, we have to convert the given expression into special notation, and after that we evaluate the expression into new notation. So we have the three types of notations. We have infix notation, prefix, postfix. Basically, infix notation is a convenient way of writing the expression which operator is placed between the operands. So basically, day-to-day life, wherever we are, basically all are using infix notations. Like we have example a plus b, c minus d. This is this expression in infix notation because the operator is placed between the expressions. We have another type of notation, that is prefix notation. So prefix notation places the operator before the operand. The notation was introduced by the Polish mathematicians and hence often referred to as Polish notation. So we are all having some example of prefix. Every time the operator will be preceding. Okay. So next also we have a postfix notation. In the postfix notation, the operator after the operands. Okay. So like we are having the example AB plus CD plus etc. So all these expressions are in postfix notation because the operators comes after the operand. So here I am having some type of a table which will give you the clear picture of the notation, what is infix, prefix and postfix. Like if we place operator in between, so this is my infix notation, and if we going to place this operator before the expressions, this is my prefix notations, and after we placing operator in the, this is having postfix notation. Okay, like this is also in infix notation because the operator is placed between the expressions, and the here the operators are previously attached, and in this the operator is assigned after, that is postfix notation. I hope all of you having the clear picture what is the infix notation, prefix and postfix notation. So let's talk about the algorithm, how to convert infix to postfix, because every time whenever you are using the stack, we have to convert these equations. Okay, so first of all, we have to push onto the stack and then add to the end of the X. Okay, so scan X, basically scan X is like we have some operators or expression, whatever the elements are going to be pushed in a stack. Okay, so we have to scan from left to right and repeat step 3 to 6 for each element of X until the stack is empty. If an operator is encountered, add it to Y, and if the left parenthesis is an encounter, push it into the stack. Basically, if we are having left parenthesis every time, we have going to push into the stack, and if an operator is an encounter, then repeatedly pop from the stack and add to Y each operator which is having the same precedence or higher precedence than operator. Okay, and after that we have to add all the operator to the stack. And if a right parenthesis in encounter, here we are talking about the left parenthesis, and here we are talking about the right parenthesis. If the right parenthesis encounter, then we have to repeatedly pop from the stack and add to Y each operator until the left parenthesis encounter and remove the left parenthesis. Okay. So I'll give you some example here. if we having some expression which is an infix and we have to convert into postfix. First of all, we are having A. After scanning the A, we just push the left parenthesis in the stack and postfix expression is having A only. After then we have plus operator. So when the plus operator arrive, we just push the plus operator in the stack. And as it is expression is having only A. When after that we are also having the left operator. So we again push the left operator in here in the stack and then we are having the B. Whenever we are having another expression, we just append this here like A and B. And if we having another operator like after B, we are having the multiplication operator. So again, we are going to push these multiplication operator in the stack. Okay. And then we are having C. So again, we are going to append the C in here, postfix expression. Okay. Then we are going to check the next. So here we are having the subtract. Okay. So minus symbol is appear. So please check whenever we having the minus and also we are having the multiplication operator and both operators whenever we are dealing with, because every time multiplication is a higher precedence than the subtraction. So we are going to pop the multiplication operator and then push it in this expression. Okay. And after push the multiplication, the subtraction symbol will come here in the stack. Okay. Then we have again parenthesis, left parenthesis. So again, this is going to place over here. Then we have D. So again, D will be going here. And then we have division. So division will be placed over the stack. And again, we are having E. So E will also going to place after the D. Then again, we have the exponent symbol. So again, exponent symbol will go to the stack. Okay. Then we have left parenthesis. And whenever left parenthesis arrive, we have to pop from the top of the stack. And that's why exponent come first, because this is my order. This is the top of my stack. That's why we are going to pop this and again going to push. Okay. So first of all, my exponent symbol will come and then division. And because we are having the closing, and so all those symbols lies between the opening and closing brackets. All those symbols will be popped out from the stack and going to push in the expression. Okay. Next, we are having the multiplication. So we are again doing the same operations and all the same steps will be followed up to the we are going to have the result. Okay. I hope all these criteria will be fulfilled by yourself. So please try to perform those numericals and every time whenever you are in dealing with the highest precedence, you have to pop the elements from the stack and then push in the expression. So we are having some advantages of postfix expression over the infix expression. And infix expression is difficult for the machine to know and keep track of the precedence of the operator. On the other hand, a postfix expression itself determines the precedence of operator. Okay, so therefore for the machine, it is easier to carry out a postfix expression than an infix expression. So here we are having some conversion from infix to postfix, like the precedence rule for converting from infix to prefix are identical. Okay, so only change from postfix conversion is that traverse the expression from right to left and the operator is placed before the operator operands rather than after them. Okay, because we are going to convert into the prefix. That's why the operator will be placed before the operands. Okay, the prefix forms of the complex expression, it is not the mirror image of the postfix. So please do not try to complicate these two terms, prefix and postfix. So we are having an example that we are going to convert the infix expression a plus b minus c into the prefix expression. First of all, we have a c. because we are going to perform the operation from here, right to left. So we are going to deal with the first of the symbol C. Then again we are having the subtract symbol. So the subtract will be going to in the stack. Okay, though then the symbol arises. So that's why we are going to push the stack, the subtract operator in the stack. Okay, then we are having B. Okay, so place the B with the C. Then we have addition symbol. So addition will be going in the stack after the subtract operator. Then we are having the A. So A will be append previous from the B. Okay. So after ending the elements, my operator will be pop out and push with the whole element. So the result will be minus and then sub addition A, B, C. I hope this will have the clear picture for you. Next, we have the conversion from postfix to infix. Every time we have to scan the postfix expression from left to right. So if the scan symbol is an operand, then push it into the stack. Okay, and if the scan symbol is an operator, pop two elements from the stack and create it as a string by placing the operator in between and the operators and push it onto the stack. So repeat step 2 and 3 till the end of the expression. So we are having an example. So here we are going to convert the post expression this into the infix expression, because first of all we are having a, we are just going push A, then we are having B, then push B, then we have symbol C going to again push in the stack, then we are having multiplication operator. So we are going to pop these two elements. Okay, pop these two elements, place the multiplication operator between them, and then push it again into the stack. Okay, then we have D, push it into the stack, then we have E, push it into the stack, then we have E, push it again into the stack, then we have exponent symbol. So we have to pop top two elements. So top two elements are E and F. So we have to pop out these two elements, place the exponent operator in between, and then again push into the stack. Okay, so next we are having the division operator. So again we are going to pop these two elements, place the division operator, and then again push into the stack. Okay, then we have G. So again push the G, then we are having multiplication operator. So we have to pop two elements. So the two elements, these are, okay, pop two elements, top two elements, and then place the multiplication between them, and then again push. So we are having this. After that we have subtract symbol. So again we are going to pop top two elements. So top two elements are these, and then place the subtract operator between them, and then again push. Then we are having H, simply push the H, and then we are having multiplication operator. So pop out two elements, and then place the multiplication between them here, and then again push to the stack. And then we are having addition symbol. So again push top two elements, place the operator, and then again push. So after performing all the operation, we are having this result. I hope all of you are fine. So next, last and not the least. So here are some advantages and the disadvantages of the stack. First of all, the stack helps in managing data that follows the LIFO technique. LIFO is what? Last in, first out. Okay. So stacks are be used for systematic memory management. It is used in many virtual machines like JVM. JVM is Java Virtual Machine. Okay. When a function is called, the local variables and the other functions parameters stored in the stack and automatically destroyed once returned from the function. Hence, efficient function management. Stacks are more secure and reliable as they do not get corrupted easily. So stack always allow control over memory allocation and deallocation. And also stack also have cleans up the objects automatically. So also, apart from the advantages, stacks are having some disadvantages because stack memory is of limited size. So that's why we can have only limited space for the stack. The total of the size of the stack must be defined before. If too many objects are created, then it can lead to the stack overflow. And then random accessing is not possible stack because every time when trying to access the element, we always access from the topmost element. If the stack falls outside the memory, it can lead to abnormal termination. I hope everything is clear now. So thank you all of you watching in this. I hope this session will help you understand the stack. Thank you everyone. Thanks for watching.